Hi there and welcome. Thank you for being a part of the first live stream for Atlas Water and Electric on this celebration of Earth Day. I'm Michaela Pereira. Ahead, we're going to introduce you to this groundbreaking technology, which could very well be a watershed moment in achieving sustainability. Ahead, you'll meet the founders of the company, you'll learn how the AWE system functions, and you'll hear their ambitious plans to address the climate and global water crisis. I introduce Brian Tochi, who is the Chief Operating Officer for Atlas Water and Electric. What a delight to have you here, Brian. Wait, that name is familiar to fans of films, especially if you're a watcher of Revenge of the Nerds, Police Academy, and so many others. And it begs the question, how on earth does a Hollywood actor get involved in renewable energy?
Well, actually, there's a corollary between being in entertainment and how I got involved. It's interesting because doing the kind of films that I've done and them being well known, it afforded me the opportunity to help out in different charities, be involved in different venues that helped others out. There was this one large charity that I was a part of, and it was a big success. And at the end of it, this one big event, at the end of it, the CEO, he came up to me and he said, Brian, if there's anything that we can do again together, let's make that happen. So I said, absolutely. So about 6 months after that, and he lives 100 some odd miles away, he calls me up and he goes, Brian, I was wondering if you could come over, plan on spending the day, and I'd like to introduce you to somebody. And I go, okay, well, who is it that you want me to meet and what is it for? He says, I can't tell you. I go, you can't tell me? He says, no, either you come or you don't. So that piqued my interest. So what happened was I arranged to go the next week. I rented a car. I drove down to his home. And when I got there, they welcomed me and there was these big monitors, computer monitors set up. And so what happened is they showed me the Atmospheric Wind Extractor. And what was so interesting is that as they were taking me through the whole process of how it works, how it operates, and what it does, I go, oh my goodness, I understand how this works. I mean, I get it. I mean, I'm not a scientist, and that's what makes this so unique. This is what makes the Atmospheric Wind Extractor technology work. It is really taking existing technologies that have been around and operating in existence for decades. They amalgamated it in a unique and patentable way to create a standalone 100% renewable energy production device that is scalable. So you can have a small system and ratchet it up to massive utility scale production output. And I go, I can't believe what I'm seeing. This can change the planet. And it wasn't lost on me. And I said, I have to be involved. And so...
And involved you are.
And involved
Chief Operating Officer, which let's jump into digging into how it is actually addressing the climate crisis, because it really kind of addresses four of the main tenets of the climate crisis: baseload, carbon capture, water production, and distributed power generation. And let's go over it one by one.
Sure.
How does AWE produce baseload electricity? Help us understand that.
Well, what's interesting is, first of all, there is no 100% renewable energy system that can create baseload power. Baseload basically is, the base amount of power a municipality, a city, a town would need to operate and function. And then at peak times, they need more, but basically it's the amount of power that they consistently need on a regular basis. That's baseload. Because the AWE systems are not only 100% renewable, they are 24/7. They operate 24/7, which is, there's nothing else. I mean, unlike wind turbines, which only operate when the wind's blowing, unlike solar panels, which operate when the sun's going, these AWE systems work consistently. What also makes this so unique is not only is it producing utility scale power, baseload, but what it also does is produces as a byproduct water.
And that's that second part.
That's the second part.
The fact that it can produce water, and it's a byproduct. It wasn't even the initial function of the AWE.
Correct.
How does it produce the water?
Well, because billions of cubic feet of air are going through the system at any given time, we are dewatering the air before it goes into the tanks.
Okay.
Let me give you kind of an idea of what the system, how it's simply put together. And what I saw from the very beginning. It basically, there's a wind capture element at the top. It's on a tower that goes down to a main flywheel. The flywheel is then attached to compressors. These compressors compress air, and the compressed air goes to air tanks. The air tanks have a 90 psi continuous flow out to another bank of compressor/air motors,
Okay.
which are connected to generators, which produce the electricity. Very, very simple. So what we do is, because there's so much air going through the system, we are able to, before it goes into the compressed air tanks, we're dewatering it. And so we're capturing that water. If you go into like an automotive center, for example, and you see you hear the lugness,
Yeah.
right? Okay, that's a compressor that's undoing them or
Yes.
putting them in. When you have a compressor, the byproduct there is water.
Yes.
You have water coming out.
Yes.
Now just take this on a larger scale.
And all of that water is the byproduct.
Exactly.
So those two things enough alone would make it a prospect worth investing in. But you add to it, it can scrub carbon. Explain that to me.
Carbon scrubbing, it's interesting. This is, again, technology that's been around for decades. What we use for the larger systems, we attach carbon scrubbers. And so because the air is going through, we're able to just filter that, capture that carbon, and actually not only remove the carbon from the atmosphere, but we're able to utilize some of that carbon for other things, carbon fibers, et cetera. It's amazing.
It is amazing. And then lastly, I want you to explain distributed power generation and more importantly, why that matters.
Okay, distributed power generation. What's interesting is, if you're in a city, we're in Southern California, and we have power companies that get their power and they distribute it through high tension lines.
Mm-hmm.
We can take power from one place and transfer it to another place. The beauty of these OS systems is that it doesn't need any third party kind of fuel. It doesn't have to be connected to the grid.
Mm-hmm.
You can literally place these where the power is needed. And so what we can do is we can distribute these in different areas where the need is.
Wow.
And without having to worry about being attached to the grid. And that's basically distributed generation.
You've explained how the system's set up, but if someone was driving by one of the systems, they might mistake it for a wind turbine, but they're functionally quite different.
It's interesting. It initiates with the wind.
Yes,
and
but that's where the similarity ends.
Right, exactly. You are so smart, Michaela. It can initiate in less than 2.5 miles an hour of wind.
That's incredible.
It is incredible, because in the wind capture elements, we have mini compressors. And that's the key, is these compressors. As it turns and it goes on rotates the flywheel, the compressors then compress massive quantities of air. And so what happens is we take less than 5% of the captured air,
Mm-hmm.
and reroute it back into the flywheel,
Mm-hmm.
and we can dial in that speed. So in essence, because we produce so much captured air, compressed air, we can use it even during no wind conditions.
I was about to ask, because there are many times when the wind is, much to a sailor's chagrin,
Right.
There isn't any wind.
Correct.
Does the off function in that case?
We can go anywhere from 13 to 14 days without wind. However, NOAA, the National Oceanographic Atmospheric Agency, which monitors, wind, water, all that kind of thing. Well, around the world, they have not found a place that was populated that has gone 15 to 18 hours without wind. So it's kind of a moot point, as far as needing the wind, needing to go 13, 14 days.
And then on the opposite end of the spectrum, in the case of extreme wind, how does the stand up?
Well, that's also the beauty of it. It is so well put together that at the top, it looks like Venetian blinds, the wind capture aspects of it. So there's like Venetian blinds that can open and close. So if there's a small amount of wind, we can keep them closed and it will rotate. During high, let's say even hurricane force winds, gale force winds, we can open up these systems, and they're all monitored remotely, by the way. We can open up the systems and let the air go, and we still can have the rotation of the flywheel dialed in at, let's say, 7 miles an hour, 10 miles an hour, 3 miles an hour.
You spoke of the compressor earlier. I mean, is that the same compressor that we all know? I mean, are these the pieces and the parts of the awe, are they off the shelf, as you mentioned, all of them?
Yes. Oh, well, this is the thing. What's so great about the, I'll repeat myself, which is saying that uh, it's technology that's been around and in use for decades. We use about 80% off the shelf parts. We have two secret sauce elements about these things.
You're not going to tell them to me.
Well, I can in a broad way.
Okay.
Okay, one of them is that we use less than 5% of the captured air to maintain the rotation of the flywheel. Okay, that's one of the kind of secrets, and we can dial in that rotation. But the key are our compressors. Our compressors are about 70 times more powerful than any compressors off the shelf, and that's where the system really takes off. So that's our secret.
Brian, thank you so much for explaining this all to us. It's very exciting.
You bet. Thank you, Michaela.